Alrighty, so today we are going to be looking at the area of a triangle. Now, you might be wondering why I have three different triangles drawn here. We'll get to that, and it's to prove a point. So, we're just going to investigate, in a similar way to other videos, how we can determine the area of a triangle. And also, sometimes it could be in relation to other shapes we already know. So, I'm going to start here first with this triangle in the middle here. This is our what we call a right angle triangle. So, it's a triangle with a right angle in it. Now, triangles have a close relationship to quadrilaterals in a certain sense. Now, if you watched my angle geometry video I did on angle sums of triangles and other polygons, your spidey senses may be tingling, and that's a good thing because there's a relation here. So, if I were to take this triangle in the middle here, and what are kind of two big parts of it? Well, it has a base here, and it has a perpendicular height. So I'm going to label here, we have B for base. It's a shocking B. Let me have another go at that. We have a base, and we have a perpendicular height, H. So, from what we know about quadrilaterals, you may intuitively want to say, well, I know from what we did with quadrilaterals that for basic introductory ones, we multiplied the two main parts we knew. So we multiplied the base times the height. Now, you wouldn't be wrong in intuitively suggesting that. But if we think about the area that we get when we multiply sort of B units across and H above, we're going to make a total area here. But that's okay because that puts us on the right track. Now, if I say multiply these, let's do that. So, if I were to multiply these, I'd get sort of like a phantom rectangle. Or this looks kind of like a square, but let's just call it a rectangle because it's probably not exactly even sides. So multiplying this base by the height, I get this total area here. But that's okay because what portion of that area does my triangle make? Well, just by looking at it, it looks like it kind of makes up half, doesn't it? So we can say here, with this particular example, I've included more triangles because, maybe this just works for right angle triangles. I don't know. But we can say from this example that our area of our triangle equaled half, which is because this was a fraction of half of the shape we made when we multiplied our base by our height. But this was half times our base length, multiplied by our height. And this being a perpendicular height because we made a 90-degree angle here. So half the base times our perpendicular height. All right, well, don't take my word for it. Let's have a look at a couple of these other ones. Now, looking solely at this one here, I want to see if we observe a similar trend as what we found here. So I have a triangle here, although it looks a little bit different, but it has, oops, it has a perpendicular height h, because all triangles do. All triangles have this height from our top vertex, our top point here, which stretches all the way down to the base of our triangle. So we call this the perpendicular height of our triangle. So I'm going to label this base. Now, what if, and I'm going to do something similar to what we did with the trapeziums we encountered in the previous video. What if I were to duplicate this triangle and flip it over? So if I made another one with the same dimensions, I've taken this exact same triangle and just duplicated it, flipped it over, and joined it together with my original triangle. Well, I get a parallelogram now, don't I? Because we flipped this exactly upside down. So this is, well, that's bad. This side is parallel to this side because these are straight lines. We've just flipped them. And also these will be parallel as well. So we have a parallelogram and we know the area of a parallelogram. We know that a parallelogram is this bottom width or base multiplied by the perpendicular height. Now, if you need more of a background into this, I'd highly recommend watching my area of a parallelogram video. I go in there, I go a bit more in depth there, but this is assuming you've watched that. So we have an area of our parallelogram, which is, I keep doing that, sorry about that, which is base multiplied by height, or the width multiplied by the height, times the height. But once again, what portion of our parallelogram does our triangle make up? Well, this shaded bit here, this blue shade of our triangle, makes up exactly half. And we can see that if we use the same kind of dimensions as our original, when we draw our new one, we get the same dimensions, and we get essentially two triangles, and only one of those is being used because that's our original area. So we'd say this makes up a fraction of half of our parallelogram that we've created. So once again, we have the base times the height multiplied by half. Okay, well, this is the same as the one here. So tick, tick, these are the same. Let's have a look at one more triangle. And I'm actually going to mess around with this one. Actually, I'm going to change its lengths a little bit. So just so it looks a bit different to the to our other triangles. Now, here, looking at this particular triangle, this once again has a perpendicular height and has a base length. Now, once again, multiplying my base by the height here, and it doesn't matter whether the perpendicular height's here or here, multiplying those two gives us a total area of this dotted line here. That's going to be our total area multiplying base by perpendicular height. Now, even here, even in a different looking triangle, in a different way that we've drawn our kind of phantom shape, our phantom quadrilateral by multiplying these two dimensions, we still see, well, okay, let's split up these two first. So let's do it like that. At our vertex, we have, okay, well, two different portions. We have this thing here and this thing here. But notice that, well, this one makes up a half of our part quadrilateral. This one makes up, visually, we can see half of our quadrilateral here. Or we could even say, well, we have four little triangles here. We have 1, 2, 3, and 4 equal looking triangles. And two of those are from our original shape. So two of ours are this shaded area of the triangle that we're looking for. So 2 out of 4, or 2/4, is an equivalent fraction to a half. So once again, our area is a half lots of base multiplied by height. And that is the formula for the area of a triangle. And we see the same thing no matter which orientation we make our triangle, we will always get this pattern happening. And I encourage you to have a play around. If you don't want to take my word for it, draw a bunch of different triangles and look at their bases and heights and make up these types of quadrilaterals. And you'll see that the original triangle you had will always make up a half portion of it. See you next time.